So today what we're going to talk about is the actual inverse trig functions of sine and cosine. So what we did before is we looked at the inverse of sine and cosine as a relation and weren't so focused on it being a function or not. So we could have an infinite number of answers. But now we want it to be a function, and that's going to limit the number of answers that we get. So those specific answers that you're going to get are called the principal values when you solve for your inverse sine or cosine. And the way that we're going to distinguish between the principal values versus every value is we're going to use a capital A for arc. So if you look here, we had a lowercase a from the last section, and that meant that we had to get every possible solution, put our answer in set builder notation. But when we want one specific answer, we're going to be using the capital A for arc. Okay, so what I'm going to do here is I want to graph, this is what the graph of arc sine looks like, lowercase arc. And you can see that it will just keep snaking its way up and down the y-axis. And of course, this graph, you can tell, it fails the vertical line test, so it's not a function. But what if we wanted to restrict our range for y to give us a function? So that means like taking this y value right there and this y value. And if I'm only looking at my graph between these two blue lines from here all the way through to there, that would be a function. And you know that after you get over here, you start repeating your values again, and then you start repeating again and again and again. So what that means is if we just looked from negative pi over 2 to positive pi over 2, we would get all the values potentially that we could get to make it a function. So the capital arc sine, when you solve for that, your y, the value of y, will be somewhere between negative pi over 2 and positive pi over 2. And you should get only one answer. So if we do that same analysis for arc cosine, here's the graph of arc cosine. What we're going to do is we're going to restrict our values going from 0 up to pi, going through here, and you can see all of these values right here now. We have not repeated ourselves, so we are dealing with a function at this point. So that means that the range for capital arc cosine is going to go from 0 to pi. So your answer for y, when you solve this equation, will be somewhere between 0 and pi. Now, can you just sit there and remember these two things? Sure, if you want to, go ahead and memorize them. But what we can also do is we can kind of compare this to using all students take calculus. And here's how you would analyze that. So first of all, what you would need to know is that your answer, your angle, is never going to be in this third quadrant. So we're going to put a big black X through the T, through that third quadrant, because we're not going to use it. Our answer is going to be somewhere in the first, second, or fourth quadrants. So if we look over here for arc sine, the range for y is between negative pi over 2 and positive pi over 2. That's from here going all the way around this way up to positive pi over 2. Well, look at your A, S, and C. Pretty much what they decided upon is that you needed two quadrants to choose from for your answer. You needed a positive quadrant and a negative quadrant. So if you look at these three quadrants, we need a positive quadrant for sine, and you're always going to use the A for the positive quadrant. So first quadrant is always going to be an option. The second quadrant has to be your negative quadrant. So between the S and the C, which of these two quadrants is negative? Well, this one for sine, right? So that means that our answer is going to be somewhere in these two quadrants, okay, for capital arc sine. If it's positive, you're going to be in the first quadrant. If it's negative, you're going to be down here in the fourth quadrant. And what you have to remember also is that when you are calculating out, say it's an angle down here that's in your fourth quadrant, you are looking at the negative angle going in this direction. Don't go all the way around in the positive, because that's going to be way more than pi over 2. But to get from 0 down here in the negative, that would go from 0 to negative pi over 2. Okay, so let's do that same analysis over here. For cosine, once again, remember that we are not going to use the third quadrant. Cosine, we're always going to have the positive quadrant be the first quadrant. And then of the two remaining quadrants, the one quadrant where it's negative is up here. So this quadrant, and then the first quadrant, look, that's the range from 0 to pi. 0 all the way to pi. All right, so that's kind of, I think, personally, an easier way to remember it, as opposed to having to remember what these graphs look like or to just memorize this range. But do what you need to do in order to remember the correct values or the correct range. All right, so let's take a look at how this can work out in our problems. We're going to have 4 examples. First example, we are calculating out arc sine, the capital arc sine of negative root 2 over 2. So the first thing that you should determine is, if we're doing capital arc sine, which quadrant are we going to be in if it's negative? And for sine, if it's negative, it's going to be down here. And then what you have to remember is that we are looking for the angle going from 0 into this direction. Okay, and so hopefully when you look at your unit circle, root 2 over 2 reminds you of pi over 4, and we're going in the negative direction, so this answer would be a negative pi over 4. And that's it. There's no step builder, nothing else, no other answer that you have to come up with. Okay, let's try number 2. We have the cosine of arc sine of root 3 over 2. So remember, we work parentheses inside out. So we're going to work with the arc sine of root 3 over 2 first. So it's positive, so that means we're in the first quadrant. If it's ever positive, we know we're in the first quadrant. So there's our array. And when you do arc sine root 3 over 2, look at your unit circle. The coordinates there's the sine being root 3 over 2. I don't really care so much what the angle is. I mean, I could technically say, hey, this is pi over 3 radians, and then figure out what is the cosine of pi over 3 radians. But all you have to do is, if you have a situation like this, you figure out there's the sine, what's cosine? There it is, it's 1/2. So you can just look at the coordinates here. But if you wanted to, you could then, replace this parentheses with pi over 3, say what's the cosine of pi over 3? Oh, look, there it is, it's 1/2. Okay, so number 3, we have sine arc sine. And I always love these because these are just inverses of each other. So they technically should just cancel each other out and you get 3 over 5. So if we take a look at it, if we, once again, worked inside out, arc sine of 3 over 5, you're going to use, since this isn't something on the unit circle, make a triangle in the correct quadrant. So it's positive, it's in this quadrant. Sine is opposite over adjacent, so 3 over 5. We can figure out that this is 4. And then pretend that this was cosine. Now you have your triangle, you say, oh, cosine is 4 over 5. You could figure out that answer. But they're asking you, what is the sine? So you just look at it, hey, it's 3 over 5. It's the exact same thing. All right. So those are always nice. And then that takes us over to number 4, which arc sine of 7 pi over 6. Once again, these are inverses of each other, right? Taking the arc sine of something, but we got to be careful because look at what quadrant 7 pi over 6 is in. We're going to be doing parentheses inside out, right? So we're going to do this first and then figure out that. So 7 pi over 6, that's right here in the third quadrant. And remember, we don't use the third quadrant. But we are going to use it, since we do have the sine of 7 pi over 6, to figure out what that actually is. So 7 pi over 6 puts us right here. The sine of it is negative 1/2. So we evaluate, what is this? Well, that's negative 1/2. Now we have a new expression that we have to solve. the capital arc sine of -1/2. So now, using our rules of our principal values, since sine is negative, that's going to put us over here in the 4th quadrant. And when we look at that, going from 0 down to this in the negative direction, that's going to be a -pi/6. So you got to be careful when they have the arc first, and it looks like it's they cancel each other out, because sometimes this angle is in the wrong quadrant. You can't use it, so you can't just cancel these out and say it's 7pi/6. Okay, so there you have it. We are almost done, folks. I mean, we're done with this lesson, but we've got one more to do, and then that's it for the year. So very nice. Have fun with this. Hopefully it's not too bad.